Okay, hi everyone. So welcome to lesson 10. So in this lesson, we are actually entering in a new chapter, so which is the third chapter in statistic. So this chapter is probability. So I think that this term will not be like so strange for you guys because you already learned this in IG also, like some of the basic of it. But some we are going to repeat it again so you can like get an idea of like what's the difference between the knowledge that you learn in IG and the knowledge that you are going to learn in A-level. Okay, so basically for this chapter we'll be looking at 4 learning outcome, which is the first one is the probability in simple cases. So mainly in this case we are talking about some elementary events, or we want to put the idea of permutation and combination in probability. So that's the first one. The second one that we are going to learn is like how to use the addition and multiplication of probability. So for the second learning outcome is actually like come together with the third outcome, which is normally we will use addition rule for the thing that is like exclusive, and for the independent events normally we will use multiplication. Okay, so don't worry about that. Then after that, the last one, the thing that we are going to learn is called conditional probability. Okay, so those are the few things that is important in this lesson. So I'm thinking to like split this lesson into like 4 videos. So the first one is we talk about what is the basic knowledge, basic concept about probability, and the second one we will talk about the addition law and the mutual exclusive event, and the third one we talk about multiplication rule and independent event, and the last one we talk about conditional probability. Okay, so with the 4 videos, then maybe you can have a more clear idea with like how the content or the subtopic goes in the chapter. Okay, so yeah, that's it for the introduction part. So again, you have all the notes here, so I'm just trying to explain everything on a white paper. Then after you look at this, then you can try to read it again by yourself. So I hope that you can like try to understand and get everything now. Okay, so the first thing is when we talk about statistic, right? When we talk about probability, then normally we have something called theoretical probability, that like for example when we roll a dice, then you know that the probability for you to get every different number or like digit for the dice, it will be 1/6. Okay, but in the reality it won't be like that. So normally what we try to do is we do something like as science. When you want to test something, then you do experiment. So it's the same thing in maths also. So we use experiment to actually describe a process that actually generate your outcome or the raw data. So like for example, if I want to find out what is the probability for me to roll a dice, then I will do an experiment. So what is the experiment? The experiment is actually rolling the dice. So maybe I won't like do it for like one time, then I will like try to repeat it and try and error and so on. Then after I collect like few of the sample, then I will come to a conclusion that what is the probability of that. So basically experiment is the process that actually we take for us to get the raw data, or what is the outcome for you in for you to find a probability. Okay, so from an experiment, then what you will have something that is called outcome. So for example, just now the experiment that we did is like I try to roll a dice. So the outcome meaning that what is the result, or what is the thing that you actually observe when you do the experiment. So the outcome for you after rolling a dice, then what you will get? You'll most probably get 1, 2, 3, 4, 5, or 6. So all of these are the possible outcome of this experiment. So these are called outcome. Okay, so when we try to put all the outcome in a set, then this set is called as sample space. So meaning sample space meaning is a set of the observation or the set of the possible outcome of an experiment. Okay, so normally sample space we will use the symbol or like the acronym S. Okay, so this is the sample space when I roll a dice. Okay, So after that, under sample space, then what do we have? We have something that is called event. Okay, so event, basically we talk about what is the set that actually defined by the one that carry out the experiment. So for example, I can have an event that I say event A maybe is the event that if I get a 5. Okay, so meaning that what is my event? My event A, the set of the outcome possible for this event is 5. Or I can say that I want an event B that I want to get an even number. So what is the possibility that I will get for event B? Then it will be for even number 2, 4, and 6. But you must remember all the event is actually under sample space, because sample space states everything, every observation that we actually will get it from the experiment itself. Okay, or maybe I can have something that like C, I want to get an odd one. So meaning what is my event C? My event C will be like 1, 3, or 5. Okay, so yeah, you know already what is an experiment, what is the outcome, sample space, and also the event. Then next we'll see what is probability. So probability is actually a measurement that tells you how likely an event will happen. So for example, sometimes we will say like the weather forecast. Yeah, when we look at the weather forecast, then maybe you will find out like how many percent of the day will it be raining on the day. So these are actually all probability. Or when we play cards, so we know that like the chances for me to get this number is like higher than the other number. So these are all probability in our daily life. Okay, so probability actually tell you how likely an event is going to happen. So probability normally is only range between 1 and between 0 and 1. So a probability with 0 meaning that it's impossible for that to happen. Okay, so basically you are saying like there's 0 chance for the event to happen, so that's why the probability is 0. So for 1 it's like certain, so meaning that I already know like yeah, you will say like 100% this thing is going to happen. So 100%, then when we change it into decimal, then it will be 1. So this is what is that mean by probability. 1 is something that you already sure that it will happen. So from 0 to 1 meaning that 0 is impossible, 1 is certain. So meaning that when you get a bigger probability, meaning that the higher chances the event is going to be happen. Okay, so the higher the probability, the higher chance for the event to happen. Okay, I think this is all quite common sense, right? Okay, so how do we find out the probability? So I think that you guys already know, like for example, if I have let's do an easy one. So like, yeah, for example, okay, I have this sample space here, so which is 1, 2, 3, 4, 5, 6. So I want to find out what is the probability for me to get event A out of this sample space. Then what you will do, the chances for you to get a 5 out of this 6 number is like 1 over 6, correct? So basically how do we do that? So it's like probability for A to happen, it will be equals to how many number of possible outcome in your event divide by how many total, or like how many events you have in a sample space. So basically like just now, if you want to find out what is the probability for event A to happen, then we will do 1 over 6. So how is 1 come from? Because I have one I have one outcome, I have one possible outcome in the event A, so that's why 1. And then when I divide, I will divide by how many number do I have in the sample space. So 1, 2, 3, 4, 5, 6. So that's why 1 over 6. So it's the same thing. If I want to find probability for B to happen, then I'll put number of B divided by number of sample space. So in this case, I have 3 in the event B, so that's why 3 over sample space, I have 6. So this is how I get 1 over 2. Okay, so it's the same thing. When I want to find the probability of C, then I will find out what is the number in C, then what is the number in sample space, and 3 over 6, which will give me 1 over 2 also. Okay, so and after that, this is something called complement. Okay, so I hope that you know, later we are trying to do some revision about the set. But yeah, A prime. Okay, I hope you still remember what is that. So this is mean complement. So complement actually meaning that what is not inside your set A. So meaning like what complement your set A. So basically when we say about complement, right, it's talk about what is the event that is not in A. So for example, like this case, if I have probability for A to happen is 1/6, so what is the probability for complement of A? Or like what is the probability that I didn't get an A? Or like A didn't happen? So how do you find that? So you know that for something to be certainly happen is like 1. So exactly A is like when you get a 5. So complement of A is basically meaning that if you don't get a 5. So if you don't get a 5, meaning that you are talking about 1, 2, 3, 4, and 6, right? So this is how you get to the complement of A is like you have 5 outcome. So that's why 5/6. So how can you do this in an easier way is that 1 minus probability for A is basically equals to the complement for the set A. Okay, so this is something that you might need to be mindful of. Then later we are trying to look at some of the question. Okay, all right. So now let's move on for the question. So I hope you can understand whatever that we are talking about here. Then of course you can try to read through the notes by yourself also. Okay, so let's try to go with number 1. Okay, so yeah, number 1. A teacher randomly selects one student from a group of 12 boys and 24 girls. Find the probability that the teacher selects a particular boy. Okay, so it's the same thing. So if you want to find out the probability of a particular boy, okay, then what you will do like you want to find out how many number of a particular boy. I mean, of course, if you want to, you can try to state this as like let event A to be a particular boy, then you don't need to write so long. Okay, then after that, N for sample space. Okay, so in this case, how many number of particular boy that you have in this event? You want to find a particular boy, then meaning you want to find the outcome that you want it to happen is like only 1 because you want to get a particular boy, right? So 1 over, then how many sample space you have? So 12 plus 24, which gives you 36. Okay, so B, what is the probability for a teacher to select a girl? So what is the probability for you to get a girl? Okay, so what you need to find out how many number of girls you have, and then after that divide by number of sample space also. Okay, so how many girls you have? You have 24, so that's why 24 divided by 36, which will gives you 2/3. Okay, all right, I think that's easy, right? Yeah, so this one is just a recap on how the formula works. Okay, so number 2, the probability of raining on a particular day in a mountain village is 0.2. On how many days is rain not expected in a year of 365? Okay, so probability of rain is actually 0.2. Okay, so they want to find out what is the day that the rain is not expected, so meaning rain is not happen. So if the probability for rain to occur is like 0.2, then how do you find the probability that it's not rain? Yeah, so you remember for a complete probability for everything that you put in a sample space, then you will have a probability of 1. So if you want to find out the probability for it to not rain, then meaning that you will use 1 minus 0.2. So in another words, meaning like if there is a chances of 20% that it will rain, then of course you will have 80% that it doesn't rain. Okay, so just like that, this is how you get 1 minus 0.2. So after you find out the probability of not rain, so basically they want to find out how many numbers of the days that actually rain. So we will try to put it in a formula. So probability of it not raining will be equals to the number of days that is not raining under the sample space that you have. So meaning like sample space is like how many trial or like how many experiment that you actually did. So probability that is not rain is like 0.2, and then you want to find out what is the number of days that is not rain, and then after that, how many days do you actually observe? So it will be a year of 365, right? So 365. So when you want to find out the number of the day that is expected to have no rain, then you will bring this up, then you get 365 times 0.8, which will give you the answer of 20292. Okay, is that alright? Yeah. Okay, so move on for number 3. So one student is randomly selected from a school. There are 837 of boys in the school. The probability for a girl to get selected is 4/7. Find the probability that a particular boy is selected. Okay, so you want to find out that out of the whole school, so what is the probability for a particular boy is selected? Okay, hold on. I know this question is a little bit confused. So you cannot do 1/837 because 837 is only for boy. But you are not selecting the particular boy from a group of boy, but you are choosing the particular boy from a school. So that's why you need to find out how many total you have, or like you need to find out how many girls you have, then you plus with the boys together, then only you can get your sample space. Okay, so you can write down first what are the information that is given by the question. So there are 837 boys in the school, so meaning that number of boy is actually 837. So the probability that a girl is selected is 4/7. So basically meaning probability to get a girl is actually 4/7. So it's the same thing. You can realize there's a complement for girl also. So like the whole sample space is like the whole school, right? So you can imagine if girl is 4/7, so how about the boy? Then the boy will be the complement for the girl. So that's why the probability of boy is basically 1 minus 3/7. So this is how you, 4/7, then you get 3/7, which is the probability for boy. Okay? So now you want to find out the probability that a particular boy is selected, then you need to find out how many sample space that you have in total first. So the question already give you the number of boy is 837, then we can try to put it in the formula. Okay, so basically the probability for you to get a boy will be equals to number of boy divided by the number of outcome in your sample space. Okay, so probability of boy is 3/7, and it will be equals to, so your number of boy is 837 divided by how many outcome do you have in your sample space. Okay, so with that you can find out what is your number of sample space already, meaning that how many students you have in the school. Okay, so when you 837 divided by 3/7, then you will get 1953. Okay, so after you find this, you didn't get your answer yet. So what is the probability that a particular boy is selected out from the school? So meaning the probability for a particular boy is chosen, okay, it will be equals to 1/1953. Okay, alright, so number 4. 3 letters word are formed at random from the word study. What is the probability that the word does not contain any vowels? So when you look at this question, right, this question is actually when we talk about the calculation involving permutation and combination. So meaning that you should learn, apply the knowledge that you learn in chapter 2 in chapter 3 also. Okay, so 3 letters are formed at random from the word study. So what is the number of sample space that you have? So the sample space that normally in this case is like the permutation or the combination without any restriction. So you have 5 letters here, so you are going to form a 3-letter word. So is arrangement matter? Yeah, because when we talk about A and D and D-A-N is going to be different thing. So that's why this is a question of permutation. So you want to try to find out what is the number of sample space first. So meaning how can you arrange it without any restriction. So that's why NS, okay, number of outcome in your sample space will be equals to, so from 5 letter you are going to pick 3 letter and you arrange it. So 5p3 will give you an answer of 60. Okay, so after that, now what is the probability that the word does not contain any vowels? So does not contain any vowels, so meaning that I don't want the U. Now what happened here? You left with STDY. So meaning that from the 4 letter you are going to pick 3 letter. So that's why for the number that does not contain any vowel, okay, it will be equals to, from 4 letter, because you already eliminate U, then you pick 3. Okay, so 4p3 will give you the answer of 24. So you want to find out the probability of, sorry, I'll try to write shortcut, okay? So probability for no vowel, then it will be your number of the possibility that you have no vowel divided by the number of sample space that you have. So that's why 24 divided by 60, which will gives you 2/5. Okay, yeah, I hope it's like something that is like quite easy for you. Okay, so yeah, let's move on to number 5. Okay, so a class has 14 boys and 16 girls, and the 4 students are selected at random. What is the probability that the selection has exactly 2 boys in it? So you are trying to select 4 students out of 14 boys and 16 girls. So meaning this is all about selection, that you're trying to like pick the boys. Then the question didn't say that you need to arrange or what. So it's basically a pure selection. So for this case, it will be combination, which we use C. Okay. So the class has 14 boys and 16 girls, and 4 students are selected at random. So you still remember, for number of outcome in your sample space is basically when you want to select it without any restriction. So that's why number of sample space will be equals to how many students you have in total. 14 plus 16 will give you 30. So 30 you are going to pick 4. Okay, so 13C4. So which will give you the answer for 13C4 is 27405. Okay, so after you get your number in your sample space, then now you see what you want to find. The probability that the selection has exactly 2 boys. So this is the number of outcome that you, number of like selection that you have when you want to have exact 2 boys. So you need to think, I want to form a group of actually 4 students. So if I have exactly 2 boys, meaning how many girls I will need? I will need 2 girls also. So basically for this question, I want to find out what is the probability that the selection has 2 boys and 2 girls. So how many boys do I have? It's like 14. So out from the 14, I'm going to choose 2. And then the same thing, out of the 16 girl, I'm going to pick 2 also. So 14C2 times 16C2, which give me 91 times 120, which is 10920. Okay, so after I get this, then I can find out what is the probability for exact 2 boys. So it's basically using 1090920 divided by 27405. Which will give you a fraction, or if you want to write it in decimal, then it will be 0.398. Alright, okay, number 6. A girl has a bag containing 13 red cherries and 7 black cherries. She takes 5 cherries from the bag at random. Find the probability that he takes more cherries than black cherries. Okay, so for this one, the same thing. So it's for this one, yeah, so you see, you want to take 5 cherries out of the bag randomly. So are you going to arrange the cherry? No, right? So this one is basically about selection, a pure selection also. So that's why this should be a combination question. So the probability that she takes more cherries than black cherries. So you have 5 cherries. So the situation for you to take more red cherries. So what are the different kind of situation that you are having now? So it's either, how do you have more red cherries? It's either like you take total all 5 cherries that you take out from the bag is like all red cherry. then of course you have more red cherry. The other one, I can have 4 red cherry and then 1 black cherry. Okay, or I can also have 3 red cherry and 2 black cherry. Okay, all this situation are actually given me more red cherries than a black cherries. So now the same thing, we try to find out what is the number of outcome in your sample space first. So NS will be equals to, so again this is like the one that without restriction. So out from 13 and 7 you have 20. So from 20 cherries you are going to make them into a group of 5. So 20 C5, which will give you an answer of 15504. Okay, so after that you can find out how many you have when you want to have more cherry, more red cherry. So the number of outcome when you have more red cherry, so you try to put in the different situation here. So meaning the first one is when I have 5 red cherry, so meaning that out of the 13 red cherry, right? So out of the 13 I'm going to pick 5. Okay, then after that 4R1B, so meaning that from the 13 cherry I'm going to pick 4, and then I also will need to pick 1 black from the 7 black cherries. Okay, and then I continue with the 13, I will pick 3, and then from the 7 I pick another 2. Okay, so this one will give me the answer of like 1287 plus 5005 plus 6006, which gives me an answer of 12298. Okay, so now you can try to put them together. So the probability for you to get more red cherries will be equals to the number of selection that you can have when you get more cherries, which is 12298, then divide by 15504. So which will give you in fraction, if you want to write in fraction, then it will be 6149 divided by 7752, or in decimal 0.793. Okay, so 7. A set of 6 cards show the number 1 to 6. 2 cards are taken at random. List down the sample space and construct a sample space diagram. Okay, this is called sample space diagram. So actually this one is not specified in your syllabus, but then one of your textbook actually taught about this, so that's why I'm just putting it as an example that you roughly know that what is happening. So basically this sample space diagram, right, so I highlight here. So the sample space diagram will be very helpful if you want to find something that we talk about, the sum between the outcome or the difference between the outcome. So how are you going to do that, right? Okay, so basically you see, now they want you to ask you to list down the sample space. Okay, so 2 cards are taken at random, so meaning that you are having a different card here. So meaning that what is the sample space that I could have here? So it's basically 6 cards, 1 to 6. So meaning maybe I will have one like 1 2, okay, or I'll have like 1 3, or 1 4, 1 5, or 1 6, correct? Okay, then after that, if I pick a 2, then I might have 2 1, and then I don't have 2 2 because I cannot, because like the card only have 1 2 3 4 5 6, so it's like impossible for me to get 2 because the cards only have 1 2 3 4 5 6. So that's why then I'll get 2 3, and 2 4, 2 5, 2 6. Okay, so can you try to finish it yourself? Then you have the last one, which gives you 6 1, 6 2, 6 3, 6 4, 6 5, and no 6 6. Okay, so that's your sample space. So when you want to use a sample space diagram to do this, right, because this question wants you to find the probability that the total score is 4 or 5. So how do you do this is with the help of sample space, then you do not need to like look at everyone and find out the total. then what you can do is there's no possibility for 1 1 to come out, then you can cross over first what is like everything that is not possible. Okay, then now you can start to do. So for the outcome that you get 1 and 2, what is your total score is 3. So 1 and 3, then you get 4. 1 and 4, you get 5. 1 and 5, you get 6, and you get 7. So same thing, if you are having 2, then it will be 3, 5, 6, 7, 8. Okay, so please check out 2 plus 6, you get 8. So it's the same thing, 3 plus 1, 4, 5, and then 3 plus 4, I get 7, 8, and 9. Okay, then 4, I get 5, 6, 7, and then 4 plus 5, I get 9, and then 10. Okay, then move on. I will just write my answer down, 11, and then 7, 8, 9, 10, 11. Okay, so all the number inside the box is basically the total score that I have if I have these two outcome in my event. So find the probability that the total score is 5. Then I just find out like what is the 5 inside here. Okay, so I will have here 5, 5, 5, 5. Okay, so meaning that I just try to find out how many. So out of how many number I have, 1, 2, 3, 4, 5. So 5 times 6, then I have 30. So my NS here, you can try to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Then you will have 30. So my number of my outcome in my sample space will be 30. Okay, then how many outcome that actually makes your total score 5 is like 1, 2, 3, 4. So that's why 4 over 30, then it will give you 2 over 15. Okay, so you can do this. So yeah, if you want to write a total one, then you write the probability for you to get a total equals to 5 will be equals to 4 over 30, which is 2 over 15. But of course, if the question didn't ask you to construct a sample space, then how can you answer? You can answer it like this. So you can write down, then let A be the event which total score is 5. So when you write down this, then you do not need to keep on copy like this. Then you can just write down what is in your event A. So event A is the total score is like 5, so that's why you write down. So which means 1, 4, and then you have 2, 3, and you have 3, 2, and you have 4, 1. Okay, so these are your outcome in event A. So when you want to find the probability for A, then it will be NA divided by NS, which is basically the same thing, 1, 2, 3, 4. So 4 over 30 will give you 2 over 15. So it's the same thing for number 4. If you want to use this, then you try to write let B be the event which the total score is 4. Then you can try to write out what is your B. So for you to get a 4, you need like 1, 2 or like 2, 1. 1, 3 or like 3, 1. Okay, so basically you have 2, so that's why probability for B will be equals to number of outcome in B divided by number of sample space, which will give you 2 over 30. So it's 1 over 15. Okay, so in another case, if you look at this, then you can see how many 4 do you have. You have like 1 here and another 1 here. So it's correct that you have 2 out of 30, which gives you the same answer, 1 over 15. Okay, so that's a pretty short part for the recap on what probability is and about some of the question regarding to permutation, combination, and so on. So next one we'll be looking at mutually exclusive event. All right.